Hello, everyone. My name is Zhiqiang Tang. I'm excited to present our work, AutoGluon-Multimodal, aka AutoMM. AutoMM is an open-source AutoML toolbox for both unimodal and multimodal learning. It's one of the three core modules in AutoGluon. The other two are tabular and time series. It supports fine-tuning foundation models with easy-to-use APIs. AutoMM supports three public modules: Hugging Face, Team, MM detection. With AutoMM, users can fine-tune the foundation models with 3 lines of code. The first step is importing multimodal predictor. We use Panda data frame as the input data structure. Next, initialize the predictor with the label column name in the Panda data frame. And finally, call the .fit API on the training data. The data can be a CSV file or a Panda data frame. After a model is fine-tuned, users may want to use it in some way. We provide 4 simple APIs for different usages. .evaluate API to evaluate model performance, and .predict and .predict probable API to get predictions and predicted probabilities for deployment. Users can also call the .extract embedding API to get embeddings from their data. Here is an overview of AutoMM. The left side shows the 3 modalities we support. The middle box contains the 3 public model rules we support. The right side provides a list of tasks. With AutoMM, users can fine-tune the foundation models on these tasks and the modalities with 3 lines of code. Next, let's go over all the tasks one by one. First, assume you want to train a text classifier or regressor. Here is one concrete example: sentiment analysis. AutoMM uses dataframe as the input data structure. Basically, each row is one sample, each column is one feature. To use 3 lines of code, import multimodal predictor, initialize it, and call the fit API. Another common task is training image classifier or regressor. Here's one example. It classifies the close images into different categories. Users need to put the local image paths into the data frame. It's also 3 lines of code: import multimodal predictor, initialize it, and call the fit API. What if your data are multimodal, image, text, and tabular? Here is one example of multimodal classification. It's called Pet Finder. Each pet has images, text descriptions, categorical and numerical attributes. Based on this multimodal data, we need to predict how fast a pet will be adopted. The API usage is the same as the unimodal. So far, you can see the same API can handle both unimodal and multimodal. You may wonder how it works. Under the hood, AutoMM detects the modalities from input data. For each detected modality, we create a corresponding model. If multiple modalities are available, we create a fusion module. It can fuse features from any modality combinations and make the prediction. The next task is text semantic matching. Here is an example. Each sample has a text pair. The label is binary, match or not match. To train a model on such kind of task, you need to initialize the predictor in a different way. The problem type should be text similarity. Query and response represent the 2 column names in the data frame. Besides the label column name, you also need to provide the match label. It tells which label in the binary labels represents the semantic matching. In this example, label 1 means 2 texts match each other. We can also specify the evaluation metric. This is a binary task, so we can use RockAUC. Under the hood, we use a text model in the Siamese network. Basically, text A and B goes through the same text encoder separately, and then we compute the cosine similarity. Besides 2 texts, we can also semantically match 2 images. Here is one example to match online products from different views. The API usage is quite similar to text matching. The only difference is we need to use image similarity as the problem type. The method we use is also similar to text matching. We use an image foundation model in the Siamese network. We forward the images A and B through the same encoder separately and compute the similarity. What if we want to match an image and the text? Here is one example. The input data frame should have two columns. One is text, the other is image. In the example, you can see the left text, a man in an orange hat staring at something, matches the semantic meaning of the right image. To initialize the multimodal predictor, we need to use the image text similarity problem type. The query and the response are the text and the image column names. Under the hood, we use the Karypis model. It has two encoders, image encoder, text encoder. We forward the image and text through them and compute the similarity using their embeddings. Next, let's look at a different task type, object detection. Here's one example, is to detect the holes on the road. To use AutoMM for object detection, we need to initialize the predictor with the object detection problem type and also provide some data samples with labels in the initialization. Another popular computer vision task is image segmentation. This example is to segment the leaf disease. In the training data frame, there are two columns. One is the original image, the other is the ground truth segmentation mask. Since this is a semantic matching task, we need to specify the semantic segmentation as a problem type. Currently, we don't support the instant segmentation yet. Under the hood, we fine-tune the segment anything model. We remove the prompt encoder for end-to-end deployment. We apply parameter-efficient fine-tuning to the heavy image encoder. The whole master decoder is fine-tuned because it's lightweighted. So far, we have introduced all the tasks. For each task, we provide the associated foundation model Zhou, and the data modalities can be either unimodal or multimodal. In the following slides, we will show their performance on different tasks. First, let's look at the results on basic tasks. We collected 24 real-world datasets from diverse domains. The dataset covers all the combinations of the three modalities, either unimodal or multimodal. We compare with AutoCarypis, which is another open source AutoMM toolbox. It's the only open source toolbox we can find that cover all the combinations of the three modalities as input. We can find the AutoMM significantly outperform AutoCarypis across all the datasets. The second task we evaluate is semantic matching. There are 4 subtypes of matching. For each type, we collected 5 datasets from different domains. We compare with Sentence Transformer. It's an open source package developed specifically for semantic matching. AutoMM as a general AutoMM toolbox gets comparable performance as Sentence Transformer, which is more a domain-specific toolbox. We also evaluate AutoMM on object detection. We collected datasets from different domains and compare with Vertex AI and NVIDIA et al. We can see AutoMM outperforms Vertex AI and NVIDIA et al. On most datasets, and it consumes the least training time compared with the other two. Finally, let's see the performance on semantic segmentation. We collected 8 datasets from 4 domains, and we compare with detection tool OpenSeg, which are 2 open source segmentation toolbox. Although AutoMM is a general AutoML toolbox, it gets comparable performance with this domain-specific segmentation toolbox. Thank you for your attention. This is the presentation of the AutoMM paper. If you are interested in using AutoMM in your task, you can find more information on our tutorial website. Thank you.